Good afternoon and welcome again. In this lecture we will be looking at the implementation of the player blueprint, so we'll be creating that and just assigning some of the base variables that we'll be using. So to do this, if we go to the blueprints folder, right click and create a blueprint class. Now I've mentioned previously that some of the different types can all be found here. The blueprint type we'll be using for the player is the pawn, because this is the one that can be possessed and receive input, which is exactly what we want. You may wonder as well, you could probably see things like the controller and the character. You may wonder why we're not using a character, and it really answers it just here. It does the same thing as a pawn. It also includes the ability to walk around. We probably don't want our spaceship walking, so we're just going to stick with the pawn. So if we press on the pawn button, going to use the standard naming convention that I have for the project, which will be bpPlayer. Simple as that. And then we'll double click to open this. Okay, so we have our blueprint open and created. Now the first thing that I like to do is I kind of take a moment to think what type of things will be needed in this blueprint. And sometimes you'll miss something, that's fine. But if I can get most of the variables in place and most of the components in place, the components over here, it just means that when I then start to really sit down and try and quickly add things into the blueprint and get things working, most of the stuff I need is there. I might need to add a few things as I go through if I overlooked a component, but it just saves a bit more time, and it means that I don't need to lose focus on the blueprinting. This may be a personal preference, but other people may do it completely differently. And this may be something that you will discover as you go along. However, I will be adding all of the variables at the beginning now. So what I'll do is, like I said, just have a quick think and I'll go through my thought process. So I know for the player, for instance, that I'm going to be giving them power-ups. I have two different types of power-up provided. He's going to be moving. He's going to come into the world at a certain location. So just from that I can think of a few variables. So the first ones I want will be booleans. He will at some point be getting power-ups. So first thing I'll check is boolean, does he have, so has power. Has he got a power-up yet? Nice and simple. And again, like I mentioned in a previous lecture, if we can keep all of the types the same as we create them, the next thing we want will be the same type, which will be another boolean. So next boolean will be whether the movement's been enabled, so be movement enabled. And that's purely because I know that we're going to have a spawn animation, and we don't want the player to be allowed to move the ship whilst the animation's playing, because that would look weird. And then the last boolean I know that we have is B has rockets, because it's going to be very important to know whether he's firing his primary projectile or whether he can fire the rocket projectile as well. Now with the spawn animation, I also know I want that to start somewhere, so we may as well create something called a spawn location, and this will be of type vector because this will be 3 points, the 3 axes in the world that we're interested in. And for now that is pretty much all that I can think that we need to know about. As I said, there's probably some variables that we will need as we go forward, and we can add those on the fly when we need them. But that will be the variables done for now. So the next things I'd consider will be what type of components will I need. So the first thing, I always get rid of this sphere. So we're going to add a scene component, just standard scene component, and place that over there. And the next thing may not be quite as standard, but I know because of the way that we'll be setting this up, we don't want to use the player's standard, the ship's standard collider. So the next thing I'll add is a collider, so box collision. And I'll just call this ship collider. So this will be the component which checks whether you're touching something else. Now this is also very important as well. The next thing, I will also want another scene component. So we'll add in a second scene component, and I will call this rotation offset. Now again, I'm using this because we're using a model which has been created to act as the player ship and an enemy ship. When I modelled this, you have to set the rotation in the modelling program, which will give you the axis it comes in on and the way that it's facing. And I figured that it would be easier to keep all of the enemies facing the left from the left side of the screen, so they were looking in the correct direction, because there's more enemies than there are players. And that way, when we need to make this change to make sure the player's rotating the correct way, we only need to make the change once rather than on the enemies. So this is what the rotation offset is for. And all we need to do with this is it basically means that the player ship will be rotated 180 degrees in the wrong direction. So in this empty component, we're just going to go to the rotation of the object and give it a minus 180 degree rotation on the z-axis. Which brings us to the next component, which will be a static mesh. So the static mesh will represent the player, so we'll call this player mesh. And over here, with this selected, we can see the static mesh option, and we will select the enemy ship 2, because like I've said, we're using the second enemy ship to represent the player ship. And then what we want to do is we want to make sure that the player mesh is a child of the rotation offset. So we just drag the player mesh onto the rotation offset, and you'll get this arrow appear, which means that it's now a child of the rotation offset. And we can also see that because this has been rotated 180 degrees, or minus 180, this has taken that value as well. So we just need to zero that out, and you can see he's now facing the correct direction. So if we imagine the start point of the screen will be over here and the enemies will be coming from this side, the player is now looking the correct way. And I'll just quickly go into why I'm doing this as well. So I've already mentioned with regards to memory usage and trying to reuse assets, using the same models can be very efficient and means that the compiler and the processor needs to draw less things into existence, and it can use a lot more of it from memory. So it will already have an imprint of this model, and it can just place it in a different part of the screen, which is a lot cheaper than spawning a brand new one and committing that to memory. There's also a gaming point of view from this as well, that the different types of enemies can be represented in a way that this will be, as I have it, the second type of enemy we see. So the first enemy is going to look smaller than the player ship. It's going to have less firepower, and you just instinctually know then that it's a pretty rubbish enemy and quite easy to kill, so you don't need to worry too much about it. But there's also an interesting game logic with that. When you see something that looks a lot like your character or an exact copy of your character, you normally know that the player is quite overpowered and is very capable in the game. So when you see something that looks just like what you're controlling, your alarm bells go off and you'll think, oh, I'm going to pay a bit more attention, this enemy could be quite dangerous. And that's exactly what we're going to do. We're not going to give it the same firepower we have, but we're going to make the enemy that uses the same model as our player a little bit tougher, and it just gives that kind of level of threat warning. So that's the reason we're doing this, for a few different reasons, and so I can get these across. But anyway, we're creating the player for now, so we'll go back to this. So if we minimize the rotation offset, we need one final thing right now, and that will be another scene component, so final scene component, and we will call this projectile spawn. So this will simply be the location that the projectile will spawn from. And I already have some values here that I know work, so we're just going to keep this on the 0 axis on the X and Z, and we'll just make this 560 on the Y. So it looks as though it comes out quite a distance ahead of the ship, but with the speed that we'll be adding this and the way that it will look in the game, this will actually look okay. I've tested that, but again, we can easily adjust this and we can come back and just move this around as needed. Finally, if we go to the ship collider, you may have noticed we didn't change the values on this, so the collider is very small. It doesn't yet represent the ship itself. So if we put this back on the 0 on the y-axis, and what we want to change is not the scale of this, but we have another thing that we can change on a collider. We can change the extent. So it's good to keep the scale at 1 if we can, because everything else is scaled at 1. So we've got a kind of uniform scale going on between all of the objects. So this is great for the ship collider because we can still change the size of it by using the box extent then. And all we really need to do is we can drag on this variable and we can change the size of this. And we can see this is then fed back in the viewport. And all we want to do is just make this overlap each area of the ship. So I don't want it to extend past the guns actually, so that is going to be 2 of the guns on the ship. About midway up those will be fine. And then we need to make sure it is as tall as the ship as well. or close to. And one thing to remember is this isn't covering the wings, but it doesn't need to, because the way that we have this on the screen, the enemy shots won't ever reach past the middle, because we're essentially lining everything up the middle, so all of the bullets will be hitting this point here. So we don't need that much of the collision to be as detailed as it could be, because nothing on this side is ever going to get hit anyway, so that won't cause a problem. So a box that looks kind of like that should be fine. So those values, I'm just going to round those off actually, because we can have that 150, 320 and 97 should be fine. Call that 100, there we go, makes me happier. Okay, so that is the collision done, and that is the player variables and the components set up. So we now have a player which is ready to spawn in the world. So what we can do, we can remove this and we can now drag him in. So we now have our blueprint ready to drag in. But we don't want to do that either, so if we just remove that, go to our player settings, go to maps and modes, and go to our default pawn. We can now change the default pawn to bpPlayer, so he's now ready to be used as part of the standard game mode. And when we start adding in the different parts of the game, that will all be automated, which means we don't need to drag the player blueprint into the level. That will be done for us. But we'll see and use that as and when we need it. But for now I'll leave that here, and I will see you in the next lecture.